So this is the data that we got by clicking on this video, but watching the thing go up and down. This is the y position going up and down. And what you want to do is you want to find maybe the acceleration there, right? In the previous video I showed you how you might find the velocity of this thing. But let's look at the acceleration. There's two ways to find the acceleration. The simplest way is to look at the y velocity, make a y velocity graph. And for some reason it's not, oh I see. It's like not showing me this. So let's, that's because the velocities are small. So I'll make this like -3 and make that +3. There we go. Okay, so the velocities vary in, in a pretty small range like that. To find the velocity, here's a spot where, by the way, it's going down, it stops, and it goes up. Remember, velocity graphs are weird, right? If we wanted to find the velocity of this little chunk, or the acceleration of this little chunk, okay, what you do is you select it like that, and then you just go analyze linear fit, right? And it puts a line through there. The slope of velocity is acceleration. So this acceleration is about 7 meters per second squared, or about 0.7 Gs, right? And so you might expect to find about 1.7 Gs, right? And then we can find out, here's a negative acceleration, right? So it was moving upward. This is positive motion. And it stopped moving upward and started moving downward, right? So it went, whoa, right? Like that. That's why it's so exciting, right? So analyze linear fit, right? Little chunk like that. And sure enough, this is, notice that it's, that's the meters per second squared, right? So that's the simplest way, right? Now, by the way, just for fun, right, we can actually go back to, that website, right? And in that folder for this thing, you'll probably find that there's data from this thing, right? There's this CMBL, whatever, okay? And Ferris wheel. Why are we looking at the Ferris wheel? Okay, because we did look at the Ferris wheel. Okay, let's go to the top. We want to go to the Froghopper, right? Okay, if you go to the Froghopper and go in there, right, you'll see these CMBL files, the vertical ones, right? These show you the actual the data from an accelerometer, an electronic accelerometer. So here's a vertical one from 2011, right? I'm going to go boom, save link as, put it right in there. Okay, and then another thing I can do is I can, so I've got this, right? Actually, I don't want to go away from this. I'll show you that in the end. Okay, so here are those slopes. Another way to find the slope, if you want to, you can go here and go, okay, why is it making that scale the same? Okay, so let's click there. Let's make that, what was it, about 10 or something like that. Okay, and then this guy is, bottom scale is, we'll make that 3. Okay, so these little spots here, notice that this is concave downward, right? So I can actually select this one here and go analyze and then go curve fit, right? We can grab that, and this is the one you want, is the 1/2 AT squared plus, right, UT plus 1/2 AT squared, or initial velocity, right? Okay, and then just, let's try it. There we go. Ooh, that fits pretty good. Look at that. Okay. So there's a curve right there. So if you recall, this is 1/2 times the acceleration. So the acceleration should be about, well, -4, right? Twice that, right? So that's another way to do it. You can select little chunks. I'll grab this little chunk here. So go from inflection point to inflection point, right? We'll analyze, curve fit, do the same thing, choose that guy. Oops, not that guy, this guy. Try that. Ooh, that fits pretty good. Look at that. Right? This is probably, I don't know, maybe more scientific or something like that. Okay, so there's a positive slope, so that's about, what, about 7.2 or something like that, right? Okay, acceleration. Remember that the A there is 1/2 the acceleration, because it's 1/2 AT squared, right? So you have to double that to get the acceleration. So that's another way to do that, right? And then, of course, the other thing you can do is, earlier in this video, I downloaded that file, right? So what we can do is we can actually, I don't want to save this, or I could save it, but I'm not going to, right? I'm actually going to open up that file, right? We can look at this and download a video. I put it in there, right? And there it is, right? The thing we downloaded from the site. You can look at it, and there's the actual video. And of course, This is 1G, this is just sitting still, right? These are the beginning and the end. These are the little hoppery things that it does, right? And of course, you can see here, this is a negative, this would be like a negative half a G, and this would be, it looks like we're getting more G's than we figured out with the video analysis, but this is the actual data, right? Hop, hop, hop. Apparently you get 3 hop cycles, and then, there it is, right? That's about all you need to know about the vertical acceleration on a Froghopper.